Okay, on this one, they're giving us hit the wrong button there. They're giving us a function, and it says it has a critical point at x equals a, find a. All right, so how do we find a critical point? So let's take the function down here. Minus 3x squared plus 8x minus 7. And so a critical point is where f prime equals 0 or plus or minus infinity. It's where the slope, right? F prime is the slope, is 0 or infinity. So let's take the derivative, see what we got. So to bring the 2 down here, be minus 6x to the 1. This is a 1 power. Bring it right because subtract 1 from the power. Bring that down, that'd be 8. Subtract 1, so it just goes away. And the minus 7, that doesn't have an x, that's just 0. You can put 0 if you want. So the derivative, we don't need that 0. So there's the derivative. Now we want to know where the derivative is 0. So then you set it equal to 0 and solve. How do we solve? You know that. Subtract 8 from both sides. Cancels that. Minus 6x, bring that down, equals minus 8, and divide by minus 6. And so x equals, two negatives make positive, hit the buttons on your calculator, and you'll get 1.333, or you could just say 4/3, right? Because you divide by 2 on top and bottom, get rid of the negatives, it's 4. But you could either put that in or 4/3. I didn't do that too neatly. Or 4/3, either one. It's good. So there's that answer. Now, at that spot, is it a local min, a local max, or neither? How do we know? Well, let me give you two ways you can know. First off, just look at this original function. What kind of graph is that? Notice it's a negative x squared. So do you know what I mean? A negative x squared graph always looks um, like that, right? It's going down. It's a U-shaped parabola, we call it, going down. So what does that mean? So that means it's going to have a max. So it's L max, local max. That stands for local max, L max. It's going to have a local max. Now, if this was a positive in the front, then this would be a U shape going up in that case, and it would have a L min instead of a L max, a local min instead of a local max if you have positive x squared. But if you have a negative x squared function, we have like negative 3x squared, then the graph's going down, it's got a local max. It's positive x squared, the graph's going up, it's got a local min. Um, yeah, that's a good way to do it. The other way is there's something called the second derivative test. You can basically take the second derivative. Here, let me get some room. There we go. You can take the second derivative. So we have the first derivative right here. We bring that down. Minus 6x plus 8. You can take the second derivative. This is another way. This will become minus because this 1 goes down, subtract 1. This is just gone. Minus 6, so it's negative. So what does that tell you? When the second derivative is negative, that means it's concave down because the second derivative tells you the concavity, which means it's like that. And so therefore it has a max. Because it's concave down, it must have a maximum value. It's an L max, a local max, an L max. That way's a little weirder. Probably you should just stick with the fact that, hey, look at this function. It's a negative x squared function. It's a U shape going down, which is going to have a local max. If it was a positive x squared function, it would be a U shape going up and have a local min. Second derivative test is okay. I'll just say this is the second derivative test. Positive means concave up like that. And so that would have a minimum. And negative, if the second derivative comes out positive, second derivative comes out negative, then that means concave down. So the second derivative tells you the concavity. We call that concavity, the way the bowl goes. So that's like concave down. It's pointing down, which means it's going to have a local max instead of a local min. So we have a second derivative negative, going to have a local max. So there we go.